So we at 360 are really excited at the tremendous interest we've been able to generate with our 360 rain videos, whether that's on the 360 Yield Summit YouTube channel or on Facebook. And with all the interest that we have, we've received some really good questions. And it doesn't surprise me, Tim, with good growers that we're introducing this to. So we thought we'd just take some time and go through some of these questions and see exactly if we can enlighten. We're super excited about the potential that rain has on raising yields. So Tim, why don't you just go ahead and start giving us a few of those.
Sure, we got a good list here, so we'll just start at the top and read through some of these. So the first question is, how does rain compensate for planter drift to stay off the rows?
Well, it's really a good question. So in our case, our receiver will be mounted on the planter and not up on the tractor cab. So the receiver will be mounted dead center on the planter. There will also be, of course, a base station in the field, but that planter will be laying down the paths that rain's going to follow. So wherever that planter goes on that 100-acre or 80-acre field, that's where rain is going to go, right down the center of that tram line.
So the next question was, why do you recommend wide drops for every row while rain only has drops on every other row? The main difference when you think about rain versus your sprayer is, of course, the speed. And in most cases, rain is running at most about 0.4 of a mile an hour compared to, in many cases, over 10 miles an hour with a sprayer. So the amount of movement that the drop experiences is dramatically different. The other thing that's very different from wide drop is the amount of flow rate that we have. So as we're dispensing water and including nutrients, it's fairly easy for water to flow on both sides of that plant, and we see that consistently in our testing. When you're applying with wide drop, the amount of volume is a lot less. That moisture is not going to move around the base of the plant itself. So the stability of the drop is much better at these speeds. And drops are still an area that we're continuing to innovate in. As you'll see the project go over the next several years, you're going to see new technology there as well, I'm sure. But that's the main reason, both the speed and the flow rate. So now looking ahead to the next question, we've got somebody here who's really interested in rain as a manure applicator.
All right.
And he's saying he's on some sandy soil, wants to apply manure in season, and they're running pivots on that field. They've got plenty of water today, and looking at adding rain to that operation. The main question here is, would our payback calculation that we showed in the main video, does that include the well installation cost? And the answer there is that it does. So when we're looking at our return on investment calculations that I showed you in the main video, we're taking into account the infrastructure that you need to add to that field, which would both be the well, and in addition to that, your electrical service. And then we're also including our best estimate today on what we think the rain system will cost as well. So when we're giving you those payback calculations, that's including the full system. Following along next, the question here is, when flooding the row like that, do you experience water running down the row, especially on the second pass of watering?
Well, what we've really noticed is that, so in our case, in the field you saw there at the plot field, we were putting on 0.3 of an inch per acre. So we were doing 1/1500ths on the way out and 1/1500ths on the way back. And it seems like that first pass, once we put that moisture on, it really softens that environment. And that second pass immediately starts to go right down into the soil profile. So we had some pretty good grades on that field. We did not see any kind of a reaction that would have been a concern. I'm excited about how I saw filtration of water going into the root system.
I think that leads to another good question here. That I think we want to cover, and that's how many acres can be covered in a 24-hour period at different gallons per minute? Can the system be calibrated to run faster or slower based off water need or availability? And I'll jump in on this one. For sure, we can adjust the rate that we apply. And I think there's another question here related to, does rain have the ability to variable rate? And the answer is it definitely does. And we're actually able to be quite a bit flexible as far as our passes that we go down in the field. So you may have a zone that you want to treat more often, and we will know based on our pass count exactly where that zone is on the field. We can send the rain machine into those passes more often, and then within the pass, we adjust the speed of the machine to vary the rate. So the faster we go, the less that we're applying per acre, and the slower we go, the more that we apply. We're not planning to adjust the speed of the well. We want the well to run flat out and use the maximum capacity of the well and simply speed the machine up to put on less water versus slowing down the well. So when you think about this calculation of how many acres can be covered in a 24-hour period and at different gallons per minute, We use the examples from last summer often of saying we put on 3/10 of an inch. Your capability though with the machine, you should think of as in terms of gallons per minute. So just over 200, say 215 gallons per minute. And that's going to vary some depending on the size of the machine. But if you use that as your math, remember we're running that well full out, 724. So you can calculate out then, multiply the minutes times the gallons per minute. And as you work the math, 27,100 and some gallons per inch per acre. Divide that out across your acres and you'll get to what you can apply in your specific field with a rain system. And in most cases, at say a 160 acre field, that's going to be a ½ inch per week. Smaller fields will be more, up to a full inch a week on an 80 acre field. So the system has quite a bit of capability to apply larger amounts than you might initially assume, and even larger than what we were applying in some of our plots this summer. So then the question relates to row spacings, and there's actually two questions here I'll put together. One is, will rain work on 20-inch rows with tram lines? And the other question is, what about multiple row spacings? We've got 30-inch, 40-inch cotton, 20-inch corn and beans also. So curious what you think on that.
Yeah, well, we definitely will be having a tram line into that planter. So for years, we've run 36-row, 20-inch planters. And we were usually putting a 28-inch tram line in for our Hagee with the wide drop and undercover. So in other words, we were taking and scooting those rows 4 inches each way, so then we had a 16-inch row beside it. So in the case of rain, on the rear tires at the 120-inch spacing, I would like to see 28 inches in that row. So in other words, it would have a 16-inch row on each side beside it. On the center tire, where the main reel body is being carried, we're going to make that a 30-inch row, so we have enough clearance in there. As we get a crop with some really tremendous earing, I want to make sure that we're going to be in a really good position to capture all that yield. So in that case, we would have the rear tire would be in a 28, it would then be a 16, and then as we move closer to that center in the 20-inch configuration, it's going to be a 10-inch, and then a 30-inch, a 10-inch, and then back again to a 10-inch, and then as we go across. So the planter can be moved. All of our planters are pretty readily able to be centered and moved, and so that's something that can happen, but yes, we should be able to do the different row configurations.
Next question is, what size of hose is used on the reel? And today the answer is 3-inch, and there may be options in the future for varying sizes, but as we're looking at the machine today, 3-inch really covers the range of what we're wanting to apply. I had a question here about, on our farm we have some that may have a creek through the middle or a waterway that's not passable. Is transport possible with 360 rain? There's a couple different aspects to that question. What's definitely fun for us is starting to see fields come in that you're submitting to our first 100 field setup there, where we're going to do the design on those, and you're seeing a lot of different variations in field shapes, and certainly these types of obstacles are part of what we're going to be dealing with. And you know, in the case of irrigation systems today, it's not uncommon to use a simple bridge system to cross waterways that are impassable otherwise, and we definitely have the flexibility to do that with rain. As well as the question here related to the ability to transport the rain system. That's something we're looking at for the future. We expect there's going to be different sizes of machines, even beyond what we just showed you in the video. And I think transport for the smaller size machine for smaller fields is something that we're going to want to take a serious look at. A question here related to handling wind. It says, looks top heavy, we get 70+ mile-an-hour thunderstorms that roll pivots. This is an interesting question for sure. You know, as you think about this idea that it looks top heavy, keep in mind that there's as much reel below the machine as there is above the machine. So actually the center of gravity is actually below the frame of the machine itself and shifted a bit towards the rear tires. And so when it comes to wind, we've done quite a bit of calculations on this. We've been through some storms here this last summer with no issues. And so I've never seen a tall sprayer blow over in a windstorm, and we're much more similar to that than what you would think of when you think of pivots that have the tendency to want to roll in some cases.
And this summer, Tim, we had a 70+ mile-an-hour windstorm come through. Unfortunately, we lost, where we live there at the dairy, a lot of large trees. And rain was running in the field just east of there, and it remained in a working condition. But at the same time, I think Tim and I need to be careful. We talk about really vicious storms, yet more to be learned. But at this time, we have been through 70+ mile an hour.
Question here of, how does the machine work on varying terrain?
Well, you know, we showed in the video my path going down into our river bottom. You know, we had a 15% grade with a 12% grade to the side. So we'll continue to learn more and more. I'm going to be challenging it this year in some of our fields where we're going to have the new rain systems running. We're going to have some pretty good grades. So I'm comfortable where we're at right at this time. I think there's more to be learned, Tim.
You bet. Question here is, does it stop the water when turning, or does it keep applying? And I think they're asking the question as it relates to the 50-yard line. So we're passing up and down that 50-yard line. In general, that is an area that we are going to water, and I see us watering that as we finish an area and we're backing out of the 50-yard line. We do have the ability to control the center section of the machine and being able to turn that off. And so we do have the ability to stop applying where we're driving. And that in general is one of the overall benefits of rain, is that where we're irrigating is next to the plant. So as you think about just going up and down following the planter pass, we're generally keeping water out of our tire tracks, and having the ability to turn off at the 50-yard line is part of that as well. Looking ahead here a little bit, question here is, will you eventually be able to just do a 60-foot system no matter the planter size and just shift the lines, and then also have section control for the boom to be able to handle some odd shaped passes? Would it not have to be the full width of the planter?
Well, we're going to have different width models, so we're going to have a lot of 16-row 30-inch planters that are 40 foot. So we'll be going ahead and working on the 40-foot boom for those growers. Most of the units that will be out this year are going to be the 24-row configuration of a 60-foot boom. But yes, as we go into the future, it's going to have the capability with intelligence on rain. This is something that it'll be able to do.
And there's a couple questions here that I think fit together pretty well. We've already had the one earlier of someone who's interested in applying manure with rain. This person here has a sow barn that's going in next to him. Question is, will it be adaptable to hog manure? There's another question I think that fits pretty well with that, of a grower here with 3,500 conventional acres and 1,200 organic acres in Minnesota. And they're interested in beta testing of rain, and they're just interested in general in everything else that it can do. And as you look at the list here of what they're asking about, from cultivators, row weeders, flamers, weed zapping, I think we're, as we talked in the main video, very excited about what the potential is for rain in the future. And we're thinking about the design of rain, both the machine as well as the software and the infrastructure behind the machine, to look ahead to what are the other things that it's going to do. And manure is definitely high on our list. We know that that's going to be a key value for rain, being able to apply manure in a banded pattern next to the plant in season. So our team's working in these areas, and we're excited to have the machine designed in a way that we are looking ahead and planning for these things to be added in the future. And this gentleman here, he's interested in 4 to 6 machines if they're able to carry those implements, and we're going to make that happen.
You know, Tim, when we think about manure, and we're a livestock operation, we have hog barns, and of course we have the dairy, and it isn't uncommon for us to write a $60,000 manure application fall invoice to our dragline company. And so I started thinking about $60,000. It becomes very attractive if I can do that in growing season and really start to bring out the most potential yield I possibly can, where we position that N, P, and K.
So I think this next question fits really well with what we were just talking about, and that is, what is the need for filtration to keep from plugging as water is drawn from lakes as a primary water source versus wells? And this is something we've thought about as well as we've been designing the system. And knowing that there's going to be a lot of cases, whether it's manure, as we were discussing before, or other types of inputs we're going to put through rain, and certainly in cases where we have different sources of water, filtration is going to be key. And rain is being designed with that in mind, as well as just the filtration systems themselves, thinking about it as a whole package that's going to go together into your operation. So that's top of mind for us, definitely something we'll be addressing, and rain will work with those kinds of water sources. Looking here towards the next question, does this unit qualify for any NRCS EQIP programs? And what I'd answer on this one at this point is, we're really excited about the potential here because of how much more efficient rain is compared to some of the other choices. If you think about water efficiency to start with, we're keeping water right on the ground. It's controlled all the way through the crop. So we're not making that crop wet where we're going to lose water due to evaporation. We're not spraying droplets in the air that's going to cause us water loss. So we're being very judicious about how we're using water. And we know that's going to show up as water savings in the future, which certainly programs like the NRCS is typically interested in are going to reward that kind of efficiency. At the same time, when it comes to nutrients, and we think about nutrient loss, the ability to start moving everything in season, even as we start to look ahead to our P and K applications, manure, certainly as we talked throughout the Q&A here, those are all things I'm excited about. So the machine is inherently a good conservation machine, and as the data gets built up over time, I think there's a lot of potential with the NRCS to have programs out there that's going to reward you for taking those steps. The next question here is, what does rain do when it gets to the headlands? I'm assuming it just drives through them and runs over some crop.
Well, Tim, what it'll do is exactly stay on that AB line, that RTK line. It's going to go right out to the ditch bank. And yes, there's going to be some on the 3 tires. There'll be a random plant that's run over as we cross across the rows. But when it comes to the actual drops and where the water's being emitted, they snake right through. We had experience over the last 2 years. You're going to see very limited any kind of reduction in plants. And so we're going to be able to water as close to 100% of the field as humanly possible.
And keep in mind with the headlands as far as running down crop, what you're looking at there is no different than the 50-yard line. You really just have the 3 tires. So it's actually a very narrow path where the machine goes. You know, all the area between the reel and the tires is kept with no issues. And so I think you'll be very surprised as far as how little corn you actually notice that gets run over. There's a few questions here that I think kind of as a last segment kind of combine together pretty well. One is related to sensors and safety on the machine, and us thinking about an autonomous machine running in your field and keeping it safe. Another one is if we have any software built to detect rain and return to home base. Another question is related to, can you control rain with an app on your phone? And also some about the GPS system we use. So those all kind of fit together, thinking about the control system for rain. And our vision for this in the future is that you definitely will be able to control rain off of your iPhone, off your mobile device, iPad as I have here, and have that complete visibility into what's happening in every rain system across your entire operation, and have complete control over every rain system, all the way out to being able to adjust the rate that it's applying in real time. We've thought a lot about safety and the importance of making sure an autonomous system is going to do its job correctly. Our team has put a lot of thought into both the sensors that we're using, as well as the logic behind those sensors to detect when an event occurs that needs to cause that machine to shut down. And in many cases, the machine is able to detect that that event is cleared on its own and it's ready to restart again. And there may be a few cases where you would get a prompt on your iPad that you need to restart the machine, and we'd give you a live view of what's happening at that point. The GPS system's RTK, as we mentioned earlier, base station, and part of the safety is around how we handle GPS. There's some details that we could get into, but you can take it from me is that we've thought a lot about safety, thought a lot about the sensors that are needed, as well as though being very careful to minimize the amount of added sensors, because we know those are also a support area that we want to keep in mind for the future. And we're envisioning rain as a long-term, 30-year kind of asset that needs to last a long time with minimal amounts of service. So there's more work for us to continue to do, but we really are focused on that and making sure that rain as an autonomous system is going to fly through that field with no issues.
Tim, there's a lot of good questions here, and I really encourage you to keep sending them in to the text line. We want to take and answer as many questions as we can. We're really excited here at 360 with the interest that rain is generating and the number of views that we have. This I know. We're all about saying, how can you and I not only raise yields, but increase our family profits?